On the surface of the moon, an incredibly valuable resource is waiting to be harvested, helium-3. It has enormous potential in clean energy, quantum computing, and advanced medical technology. Helium-3 is becoming the gold rush beyond Earth, attracting attention from nations around the world. But why is every major country racing to secure it? Helium-3 is extremely rare on Earth. Most of it comes from the decay of tritium in nuclear weapons stockpiles. The annual supply is only a few thousand liters, far too little to meet the growing needs of the quantum industry. One of its most important applications is in cooling qubits for quantum computers, allowing them to operate at extremely low temperatures and with reduced errors. Without helium-3, large-scale, reliable quantum computing would remain out of reach. Beyond computing, helium-3 is a perfect neutron absorber. It enhances the sensitivity of radiation detectors and improves the quality of MRI scans when polarized. And perhaps its most promising use is in nuclear fusion. Fusion reactions using helium-3 produce charged particles instead of neutrons, which means far less radioactive waste. This could provide a virtually limitless and clean energy source for humanity. The moon offers a solution to the scarcity of helium-3 on Earth. Over millions of years, solar wind has deposited helium-3 into the lunar surface, or regolith. Scientists estimate the moon may hold up to 1 million tons of helium-3, though it is dispersed at very low concentrations. Extracting it will require processing enormous amounts of lunar soil, but the potential rewards are immense. This growing importance has triggered a global race. The United States and China are the two main competitors, each seeking technological and strategic advantages. Russia has publicly expressed its intent to join, while the European Union, India, and other nations are beginning to establish their presence on the lunar frontier. Helium-3 is not just a resource, it is a strategic asset for the future. Mining helium-3 on the moon presents enormous technical challenges. The lunar soil is abrasive, filled with fine, glassy particles that stick to machinery and wear down mechanical joints. Even the Apollo astronauts experienced difficulties with dust clinging to their suits and tools. Moon gravity is only 1/6 of Earth's, which affects the operation of moving parts and causes lubricants to evaporate. Remote control from Earth is limited by signal delay, making autonomous systems essential. Once lunar soil is collected, extracting helium-3 is no simple task. The gas must be released by heating the regolith to high temperatures, then separated from helium-4 and other volatile compounds. This requires advanced cryogenic systems or specialized membranes, all powered by a significant energy source, whether solar panels or small nuclear reactors. Processing hundreds of tons per hour remains one of the greatest technical hurdles. To tackle these challenges, companies like Interloon in the United States are developing innovative solutions. They are building small, mobile harvesters capable of scooping lunar soil, heating it from within, and discarding processed soil as they move. Prototypes have been tested on Earth in reduced gravity flights, and traditional machinery has been miniaturized for deployment in space. Safe storage and transport of helium-3 back to Earth are also being addressed simultaneously. The potential market for helium-3 is already taking shape. In 2025, the U.S. Department of Energy purchased 3 liters of helium-3 from the moon, marking the first government purchase of extraterrestrial resources. Private companies such as Maybell Quantum and Microsoft have signed temporary agreements, preparing to expand quantum and cryogenic infrastructure once a stable lunar supply is available. Helium-3 is a strategic resource, offering opportunities in clean energy, advanced computing, and medical technology. The race on the moon combines immense technical challenges with high-stakes strategic competition. In just a few decades, the moon could become humanity's ultimate gold mine, transforming the way we power our world and explore the universe.